Hello, welcome to Chingster's video on correlation, causation, and linear regression. So we want to just now review about univariate and bivariate data. So univariate data is just one discrete data. For example, just number of students, okay? And bivariate data will be a data set that has several different characteristics that can be measured using two different quantities, and they are interrelated. As you have learned a scatter diagram or scatter plot in IGCSE, so we're just going to go through a quick review. So when describing a scatter diagrams, you should be looking at the following patterns: association, form, and strength. So association, if the patterns goes up from left to right here, it has positive association. If it moves down from left to right, then it has negative association. The form is general shape. So this is the general shape. So association would be either positive or negative. And the strength would be determined by how closely the points follow the specific association and form. So for example, if you look at the first one, this is going up. So this is what we call positive. I'm going to use the word correlation here. So the correlation measures the direction of the association and the strength of the linear relationship between the two variables. And the second one is going down. So this is negative correlation. And the third graph, you can see that it is scattered everywhere. This is what we call no correlation. This occurs when the points are randomly scattered. So the first one, you can see that when the independent variable increases, the dependent variable also increases. The second one is where the independent variable increases, the dependent variable decreases. And let's look at the strength. So the first one would be, you can see that they are very close to the line. We consider this as strong. We don't have a correct graph here. If we have a graph looks like that, this is what we call moderate. And the third graph should be scattered everywhere. If it's going just same direction. So, and this is what we call weak. Okay, so the graph should look like that, and then spread out, and then very spread out. Linear regression. A line of best fit is often an inaccurate measure. Therefore, a method called linear regression is used to find the equation of the line that best fit the data. So we always look at R value, the product moment relation coefficient, and it's given by the formula Sxy over Sx times Sy, which is the sum of the product of x times y, and divided by the square root of the sum of x squared times the square root of the sum of y squared. Okay, so we're not going to calculate this manually. We're going to use GDC to help us calculate the R value. So let's look at it. You can see that for the R value, if it's 0, it is there's no association. Then we have -1 being strong negative and 1 being strong positive. So let's look at example 5. The following table shows the percentages of 10 students in English and humanities exams. So use your GDC to find the regression equation. I hope you remember how you could use your GDC to find your linear regression. Remember to enter the two lists and then get the linear regression. So the equation, can you pause the video now and enter this into your GDC? And the answer should be y is equals to 0.528x plus 38.7. So, and generate a scatter plot on your GDC and insert the equation from part A. Describe the strength of the association between the exam results in English and exam results in humanities. And you can see that if you enter that in, you will see that the R value is roughly around 0.863. And in this case, we would say that there is a moderate positive correlation between the exam results. Now we're going to try calculating the R value by hand, and let's see what it means. So using the data from example 5, find the product moment correlation coefficient of the data and compare it to the R value the GDC gives you for this data. So I would just fill in all these values here, x and y. This is x squared, this is y squared, and this is x times y. So we have 92, 18, 88, 20, 30, 80, 60. I'm going to fill up all these values here. From here, the sum of x will be equals to 528. The sum of y is equals to 666. The sum of x squared is equals to 34,464. And the sum of y squared is equals to 46,820, and the sum of x times y is equals to 38,640. There are 10 students in the data set, so n is equals to 10, and we know that the mean will be equals to sum of x divided by n will be 528 divided by 10. I get 52.8, and the average or the mean of y will be 666 divided by 10 will be 66.6, and we have SXY will be the sum of x times y divided by n minus x times the mean of x times the mean of y, so it will be 38640 divided by 10 minus 52.8 times 66.6. I end up with 347.52, and the next one is the SX squared will be, I take the x squared divided by n minus the mean of x squared, so it will be 34,464 divided by 10 minus 52.8 squared. I end up with 658.56. And as y squared will be equal to the sum of y squared divided by n minus the mean of y squared, so it will be 46,820 divided by 10 minus 66.6 squared, and I get 246.44. So the R value will be equal to SXY times SX times SY, and there will be 347.52 divided by the square root of 658.56 times square root of 246.44, and that is approximately equals 0.8626, and is very close to our R value in the calculator. It's the same way they're calculating it. So this is indicating a moderate positive linear correlation. In example 7, a student obtained a mark of 75 on an English exam but was absent for the humanities exam. Justify the data using the regression line equation from example 6 and example 5 and to predict the grade that he will obtain on the humanities exam and find his exam grade. So since 75 is within the English exam range score of 18 to 92, and the data showed a moderate positive correlation, so the regression model could be used. So y is equals to 0.528x plus 38.7. So 0.582x would be 75 in this case. So it's 38.7. And then I can say that it's about 78.3 marks. So the student would be obtaining about 78 marks, the mark of 78 marks. Okay, and for part B, if another student was absent for the English exam and his grade on the English exam was 20, state with reason whether it's justifiable to predict his English grade using the regression equation. Since 20 is outside the data range, okay, since 20 is outside the range of data for the humanities exam, because I think y is between 42 and 100, it would not be reliable. There are some vocabulary and terms that we need to understand for scatter plot. So interpolation is predicting a value that is within the smallest and the largest value. Extrapolation will be predicting a value outside the smallest and the largest values. It's more like outside the range between the smallest and the largest value. So the accuracy of interpolation depends on how linear the data is. It can be gauged by the correlation coefficient. The accuracy of extrapolating depends not only on the original data but also assumes that the relationship attends outside the data that we have collected. This depends on the situation under investigation and is unlikely to be reliable. And there are also some correlation fallacy. So correlation versus causation. So basically, a scatter graph often shows the relationship between two different variables of a data set, but it does not imply that a change in one variable will cause a change in the other. This is called the causation effect. For example, it is not a good example of a relation between run 1 and run 2 of a ski race to say that the time in run 2 was slow because the time in run 1 was slow. And next thing is that correlation is only linear. This is so using the correlation is only allows recording of linear correlation. So but you can see that sometimes scatter plot we have non-linear correlation. For example, it could be the regression could be quadratic, it could be logarithmic, or depending on the situation. And the theory of the third variable, this fallacy is very common. The theory of the third variable states that there exists a third underlying variable to which the two variables may be related. So time is a common third variable. For example, during the years 2000 to 2015, the number of detox juice bars opening in London and the frequency of knife crime in London were recorded. So the data show a high correlation value. Clearly, the third variable, time, played an important part in the correlation study. Next fallacy will be the spurious mathematical relationship, could be ratios, fractions, or addition. So it is essential to ascertain that there exists a mathematical relation between the variables which might give rise to an invalid correlation. For example, if a relationship is required between a student's math HL grade and total diploma scores, points because the math grade forms part of the total diploma grade, then careful examination must be made before correlation analysis can be applied. And also the next one is combinations from separate populations. It is essential that the data set arises from one homogeneous population rather than two distinct groups. Last one is incorrect sampling techniques. As in the previous section, the way that the data has been collected also plays an important role in correlation analysis. We have reached the end of the video. Please do more practice on your own in exercise 5I, and see you soon. Bye.